I just throw it back together after testing.
Mr. Townsend, can I go get a sheet from the first floor office for the homecoming, prom thing for our guests?
He's gonna be back in time.
I mean, I think I'm just going right down there and just coming straight back.
You're gonna be more than a minute late.
Okay. Well, I can count it tardy if I'm.
If you're
I'll be quick.
Run, man.
Should I take a pass or?
No. Okay, I guess the bells are turned off, but we need to get started here. So to start off today, I need y'all to get out the 3 handouts from last class. That would be 109, 110, and 111, please. So today we've got a little bit shorter class period, but we need to finish up the linear stuff from last time and move on to the next leg, which is quadratics this time.
Oh, I know that. Because he just used all these big words.
I know, big word I did not know.
I'll let you know if you do that.
Okay, so before we keep going on the linear stuff from last time, I want to do about the 2-minute version of what we did on worksheet 1. So just a quick little refresher about the type of things we were trying to do. So before we looked at questions 1 through 4, I talked about what point slope form was versus slope intercept form. And I remind you a couple ways to find slope, like rise over run or slope formula. So given 2 points, questions 1 and 4, we could find the slope with the slope formula, plug in a point into point slope, and then we were basically done. For question 2, we had to remember a few different things about horizontal and vertical lines to be able to do that one. And on question 3, we needed to remember a couple of things about parallel and perpendicular lines. All of that is stuff that's good for you to know for the ACT as well as calculus. But question 5 and 6 were a little bit different. These probably were not familiar to most of you, even if you did them in Algebra 1. So those 2 questions were about direct variation, and we'll put a little more focus on that today, since that should be less familiar to you. But really, the 2 things you need to know about direct variation are highlighted there. It goes through the origin, and instead of calling the slope, we call it the constant of variation. On the back page, we graphed a few lines, put it in slope-intercept form to graph it, graphed it because it was a vertical line, graphed number 10 by knowing what absolute value of x looks like, and graphed a piecewise function for number 9, 3 different pieces. Number 11 was switch into mx plus b, y equals slope-intercept form. And then number 12 was probably the hardest question, so that'll be one that gets a little more focus here the first 20 minutes of class today. Taking an absolute value function and switching it into a piecewise function. Okay, so you guys have to remind me because each of my classes were in a different spot. I think y'all were a little bit further ahead. Didn't I give you enough time to finish worksheet 2 and we just didn't go over it? Yes? Okay. So I'm going to do not the 2-minute version, but I'm going to go over all of worksheet 2, and then at the end I'll pause and let you ask about more specifically. So if you checked your answers to worksheet 2 on the website, I think the solutions have been up there. I guess you know which ones to pay attention to, but short of that, you need to pay attention to all of them. All right, worksheet 2 is just like worksheet 1, except for questions 1 and 2. 1 and 2 were not on worksheet 1, but this basically just means plug -3 in for x, and solve for y. So you get 18 minus 1, or 17. Plug 1 in to f of x, and then multiply it by 2. So 2 times 1 should give you 2. Unless my arithmetic's off, those should be fine. Again, I'll just take questions at the end. All right, 3, 4, 5, and 6, we're asking you to make equations of lines. So just like the other worksheet, I'm going to do 3 and 6 first because they both give you 2 points. So I would be aiming for point slope. If you have a point, the y value goes in place of y1, the x value goes in place of x1. And then the only thing keeping you from your answer would be the slope. But if you're given 2 points, you can just subtract the y values over subtract the x values in the same pattern. Looks like -4/3. Now, I can't work every one of these every single way, but again, if you really just wanted this in slope-intercept, that would not be wrong on the quiz, but you would need to distribute this and then add the 5 over, and you're going to have to deal with fractions that way, so why bother? Just leave it in point slope. Okay, question 6, basically the same idea. Plug in a point into x1, y1, subtract the y values over subtract the x values to get the slope, 4/3. And the only thing I would probably have done here is subtracting 0 doesn't do anything, so I probably would have stopped here. If you want to add the 4 over to put it in slope-intercept, then that's fine, I guess, but there's no need to. So those two are basically the same thing. If you know what point slope, why it's strong, you know it, what its form is, like a formula, plug in 2 of the 3 numbers you need, find the last with the slope. Back to question 4. This one gave us a point. So again, if you know point slope and how to plug that in, you're almost finished already. Last thing is thinking about the slope. But instead of giving 2 points, they told you it was horizontal, and horizontal lines have a slope of 0. So I guess this is technically correct, but timesing by 0 makes all of that go to 0. And really, if it's a horizontal line, it'll always be in the form y equals a number. So if you add that 5 over to go through -4, 5, it had to be y equals 5. Horizontal line has all the same y values no matter what x is. So the way we say that algebraically is to say that y is always 5, regardless of what x is. That's why there's no x's here. All right, number 5. Again, the first half of the work is the same. Plug in the point slope, and then the only thing left is thinking about the actual slope. So if you have 2 points, slope formula, if it tells you it's vertical or horizontal, plug in the slope that you memorize. If it's parallel or perpendicular, you need to know that parallel lines use the same slope. If it had said perpendicular, you would want to use the opposite reciprocal slope, which would have been -1/2. But since it said parallel, you should have used the slope of 2 again. Okay, so you might feel a little rusty on those things, but I know you have practiced a lot of that stuff. And again, that's stuff that you need to be good at for calculus, college algebra, pretty much any of the next math courses except for maybe AP Stat. Okay, but 7 and 8 require a little bit more focus from you, because these two you may not have seen in Algebra 1, just depending on your teacher, and even if you did, you probably didn't practice them enough to where you still remember them today. So again, there's really 2 things you have to know for these, and then it's not any more work than the first 6 questions here. Direct variation, it's implied that it goes through the origin, and instead of saying slope, we say constant of variation. That's the only things you have to know in addition to be able to work these. Because if you know this one has a 0.00, this is like question 3 and 8. You have 2 points, write the equation of the line. Plug in the point and the point slope. Once again, our last hurdle is thinking about the actual slope. But since we have 2 points, we can just subtract the y values over subtract the x values, and a moment later you should have gotten that the slope was 7/3. Okay, question 8 is also constant of variation, direct variation. It's asking us to find constant of variation, which again is just a fancy word for slope, and find the y value when x is -3. Well, because it's direct variation, I know it goes through the origin, and then that gave me a second point. So subtract the y values over subtract the x values. Dividing by -1/4 is the same as multiplying by his reciprocal, and you should end up with -8. So again, as long as you know direct variation goes through the origin, and you know constant of variation just means slope, I'm not doing anything uniquely different here that I haven't done on this worksheet already. But then to find the y value, honestly what you need to think of is this is where the equation comes in handy. So I know it says doesn't say you have to do the equation, but the equation is like a formula that will tell you all of the points on that line. So if I plug in one of the points, like 0, 0, and plug in the slope, The equation of that line is y equals negative 8x. So y is always whatever x is times negative 8. So negative 3 times negative 8 should have given you positive 24. Again, there'll be a chance to ask for questions here in about 5 more minutes. So you guys should have already tried this, so you should know which ones you struggle with. Okay, and then a few of the graphing questions. So if something is not in mx plus b format, you might want to put it in mx plus b format. So subtract the 3x over, divide both sides by negative 1, and then it's in mx plus b. B represents the y-intercept. There's 1 point. The slope, you can count up 3, right 1 to get a second point, and you really only need 2 points to define a line. But if you want to go up 3, right 1 a couple times, it'll make your line look a little more accurate. So put it in mx, solve for y equals, put it in mx plus b, and then know what those two things means. Y-intercept, slope. Y-intercept, slope. Number 10 is a vertical line. I recognize that by its equation type, and he's the line where x is always negative 4. No matter what y is, x is negative 4. Okay, number 11 is another one that we'll get a couple more questions of practice in the next handout. But you should have graphed y equals 4, but only kept this part of it, where x is equal to 3, close circle, and greater than 3, the stuff to the right. Then you should have graphed y equals 2x minus 3. But only keep the part where x is greater than negative 1, that's an open circle, and less than positive 3, that's an open circle. Everything in between. I know these are both open circles because we didn't include here. It didn't include the equal to part. And then last part to finish this one, it was supposed to be y equals negative 2, which would be this line. But you should have only kept it where x is equal to negative 1, close circle, or less than negative 1. So I graphed all 3 pieces, get this piece of this one, that piece of that one, and that piece of that one. Completely optional, but I think it's a good idea. Realize that this is saying it's a function, and if something is a function, your final answer cannot be correct if it doesn't pass the vertical line test, including x equals 3 and including x equals negative 1. It can only hit your graph at 1 point. Close circle, open circle. Hits here, doesn't hit here. Close circle, open circle, hits here, not here. It only hits 1 time. Okay, for question 12, this is trying to line you up for the last question, but this is going to look like the absolute value of x, and then transformation, shift it right 2. Okay, first graph, I put in slope-intercept form to help me graph it, but question 13 specifically asked me for that. So you could subtract the 2x over, and you could divide everything by negative 3. And then that is slope-intercept because it is written as mx plus b, y equals mx plus b. Okay, and then probably the most challenging one is number 14. So I'm going to, I don't know, instead of just saying the answer real quick, I know we're going to need to talk about this more on the other handout, but I think it's still valuable enough that I go through this one, this basic example. This is square root of x. Sometimes it looks like this, sometimes it looks like this. So right here in red, this equation is y equals x, and here in purple, this equation is y equals negative x. The reason I like to point this one out to you is because it helps you see what your first part of your answer over here is supposed to be. This red stuff is the stuff under the absolute value sign. So over here, 3x minus 4 it's going to be one of the parts, the stuff under the absolute value sign. The other part was the opposite of the stuff under the absolute value sign. So that's going to be the same here. The opposite of the stuff under the absolute value sign. Or you can distribute. Now here I can see that this is switching at x equals 0. So this is to the right, this is to the left, and we need to include 0. Over here I've got to put a little more thought into it. That makes this question a little bit harder than this one. Since this is subtracting from x, I know it's going to the right sum. So there's kind of a quick visual. This would be the part that has a positive slope. And if you imagine him keep going, he has a negative y-intercept. This would be the part that has a negative slope and a positive y-intercept. But even just making a far from accurate picture here is going to help you with this, help you with the constraints. Because you could see they're switching places. It stops being purple and starts being red when y equals 0. Bless you. So you can either set this equal to 0 and solve, or this equal to 0 and solve. And I will actually do both to show you that you get the same thing either way, so it doesn't matter. Because where this y value is 0 and where this y value is 0, they're both the same spot. So subtract 4, divide by -3 would be 4/3. So this is happening at y equals 4/3. So I want this one to the right of that, I want this one to the left of that, and to make sure I actually include this point, I need to include one of these but not both. Doesn't matter which one. Now again, I know that's quick, but we've got 2 more we're going to look over on the other handout. This is more or less trying to help you see what you did correctly versus what mistakes you may have made and what may require a little more attention than some of the other stuff. So before we move on to the extra practice, in fact, practice 3 of those question types one more time, is there anything you guys would like some clarification on from worksheet 2?
Can we see number 8 again?
You have a question about 8 or just looking it over?
I was looking back at my notes and it was right. Would the answer be 24?
The second answer is yes. It asks for 2 things. That's that part of the question. But there was also this part of the question, which was basically asking for the slope. It had 2 parts. Okay, so again, I'm not trying to rush you guys on this, but you should have already practiced this, so it was really just trying to help you see what you might need to ask about. Anything else you want clarified before we move on to the last part of this? Okay, then to finish up the linear piece of this, let's move on to the extra practice. This is what I gave to you on last class. This is one you already have, so you didn't pick it up today. So what I want to do is I want to work one more example of these, not so quickly as I did on the other one. One more direct variation question, graphing one more piecewise function, and changing, well, I'll do 2. I'll do 5 and 6. Changing an absolute value into a piecewise function. I'll just go a little bit slower, just one more chance for a reteach. Then I'll give you a few minutes for you to try 2, 4, and 6, which are the same type of questions, but you get one more guided practice question that way. Then we can move on to quadratics. Okay. So similar to question 6, find the direct variation. So as soon as I see that, what's going on in my head is it goes through the origin, and slope is called constant of variation. You just have to memorize those two things go with direct variation. There's no way around that. Okay, so they give us a point here. When x is -5, y is 4. And because it's direct variation, they're really giving us a second point. So the constant of variation, since it's really just slope, you can subtract the y values over subtract the x values and get -4/5. There's the constant of variation. Now again, if you don't know it goes to the origin, you only have one point and you're going to be confused. You have to know it goes to the origin for that second point. Okay, second part of the question wants to know find. Oh, okay, I'm sorry. I did that wrong. I did not read this very carefully. Second part of the question, find y when x is -5. The point, though, sorry, this is supposed to be -1. And dividing by -1/2 is the same thing as multiplying by -2. Sorry, -8 is what we should be going there. I glanced at the numbers too quickly. Okay, now there's other ways you could do this, but I think the easiest way to find this is to write the equation of the line out. You get to pick your point if you're doing point slope. Using 0, 0 is a lot easier than using -1/2, 4, and you get that option. So the equation of that line, even though nobody asked, is y equals -8. The reason why I think you should still do that is because it's the formula that will tell you all of the points. Y is always whatever x is times -8. So if x is -5, -8 times -5 should be +40. Now I'm about to move on to question 3, and then 5 and 6, and then I'm going to ask you to come back and do question 2, 4, and 7. So is there anything you want to ask about what I did in direct variation for question 1? I'm not saying anything different, I'm just reminding you, you've had the weekend between this and you haven't thought about it. Okay, so one more reteach of piecewise function. Again, piecewise function can be 2 parts or 5 parts or 3 parts. This one happens to be 3 parts. So I would just graph all 3 of these. Y equals 5, horizontal line. Y equals 2x minus 5 is then slope intercept. So I have the y-intercept and the slope. And the last part is y equals -6, which is another horizontal line. But it's called a piecewise function because you should only be taking a piece of each of these. Y equals 5 is supposed to be equal to at x equals 4 and bigger. That's the stuff to the right. So not the stuff to the left. The middle piece is only supposed to exist between -2 and 4. So he doesn't include -2, open circle. He doesn't include 4, open circle. It's everything in between. Nothing to the left of -2, nothing to the right of +4. And finally, y equals -6, but only when x is equal to -2, close circle, or less than -2, stuff to the left. Even better is if you take 5 more seconds and think about this guy's a function, so he's supposed to pass the vertical line test. Mine certainly passes the vertical line test. Even at x equals 4, it only hits once. Even at x equals -2, it only hits once. That's why the open circle, closed circle is important. If you make these both closed circles, it's not passing the vertical line test. That can't be correct. Okay, so I really think you just boil it down to that. Graph this, keep this part. Graph this, keep that part, and graph this, keep that part. But is there anything specifically you would like to ask about piecewise? Okay. Then the third question type that students used to ask for more practice on, which is why I made this handout, was the ones changing the absolute value equations and the piecewise equations. So again, I really feel like understanding this one is the key to helping you understand the other ones. So number 5 is not one that you're going to see on the test, but again, if you understand why 5 is set up the way it's set up, it will help you set up these others as well. So on question 5, sometimes the equation is y equals x, the stuff under the absolute value, and sometimes it's y equals negative x, the opposite of the stuff under the absolute value. So on question 6, I can do half of it that quickly. Half of it is going to be the stuff under the absolute value, and half of it's going to be the opposite of that. So the negative version. Either put parentheses or distribute. This one, just knowing what the graph looks like, I can see that it stops at 0, or it stops being this one and starts being this one. So it's this equation when x is less than 0, it's that equation when x is bigger than 0, and to make sure that this point down here is included, I need to include one or the other. Not both, not neither, but otherwise it doesn't matter. So same thing over here. I need to think about when does it stop being the purple function and start being the red function. Now even though I don't know exactly what this looks like without some work, you should know that if you're adding to x, it's going to move it to the left. You should know that the graph still looks like a V. And you should see that it's switching from negative slope purple to positive slope red right here, specifically where y equals 0. So you could either figure out where this guy equals 0, negative 1/2, or you could figure out where this guy equals 0. Also negative 1/2. The same value it's supposed to be. So at negative 1/2 is right here. This is x equals negative 1/2. So to the left of that is when it has the negative slope. To the right of it is where it has the positive slope. And to make sure you include this point on the x-axis, include one of these. Doesn't matter which one. Just make sure you include one of them. Either one is correct. So again, this stuff is just the stuff under the absolute value or the opposite of the absolute value. This is where y equals 0. It's obvious here, but over here I actually set one of them equal to 0 to solve. And then just be careful with your inequality signs. You need to make sure that they're pointing in the correct direction. Okay, so this is honestly the last practice I have for this, so you guys need to give it your best effort here so that you really know if this is sunk in the way it needs to be. But I'm going to set a timer and give you guys a few minutes so that you can try one more direct variation question. Try it without looking at question 1 as much as possible. Try one more piecewise function graph. Try to do it without looking at question 3. If you really know how to do it, you shouldn't need to look at question 3. And try one more changing absolute value function into a piecewise function. Try to do it without looking at 4 and 5, but if you need to, at least mark what stuff you needed to look at. So let me give you a few minutes to try those. I am going to freeze my screen and work them out at the same time, and then we will check, compare, make sure that there's nothing you want to clear up. But this linear part of the unit, there is no book assignment, there's no extra practice other than a test review, so you really need to take advantage of this one last opportunity to make sure this stuff, that you're capable of doing this stuff, that there's not some misunderstanding.
before class?
No, I just didn't know you
Okay, we'll give it a few more minutes here. Sorry, I thought y'all needed a lot more time. Okay, I gave you guys a few minutes head start, but let's check our answers and make sure you don't need to clarify anything before we move on to some quadratic stuff. All right, so 2 answers for number 2. The constant of variation was 3. It's just a slope formula. And then when x was 3, y would be 9. I made the equation of the line, plugged in 3 for x, and solved for y. Anything you disagree with or want to ask about? Okay, then your piecewise function, number 4, should look like this. Y equals x, but only when x is greater than or equal to 5 in red. y equals 2, but only when x is bigger than -4 and less than 5 in purple. And y equals -x minus 5 in black, but only when x is equal to -4 or less than -4. Any of those you disagree with or want me to explain in more detail? Okay, and then the last one. Changing absolute value of 4x minus 2 into a piecewise function. Again, I feel like this part should be pretty quick. Part of it's going to be the stuff under the absolute value sign, 4x minus 2. The other part's going to be the opposite of that, negative 4x minus 2, or distribute the minus to make it negative 4x plus 2. The part you're going to need to slow down on is probably this part. So, since this was subtracting from x, I knew it moved a little bit to the right. You can see I made a visual. Positive slope, 4, so I made this red, made this 4 red. Negative slope, -4, I made it purple, made the line purple. They switch at y equals 0, so I set one of these equal to 0, either one you want because they're going to give you the same thing. That told me that handoff was happening at x equals 1/2, and then I just need to be careful that I pointed these the right way. The positive slope one was supposed to be to the right, the negative slope one needs to be to the left, and then to include this point, you can either include here or here, but not both and not neither. But either one would be acceptable. Okay. Anything with that you want me to address or go over again? Okay, so just from past experience, most of you would probably benefit by looking at these extra practice questions before we get to your next test. But I guess there'll be a few more of these on your test review. So, okay, so let's shift gears here. That's all the linear stuff we want you to know. So again, most of it you should remember or you should be wanting to recall anyway for the ACT. There are a few things sprinkled in there, of course. But for the most part, you shouldn't feel like you need to go and study the linear stuff for hours. Or if you do, you need to start chipping away at it. Now we're going to look at quadratics, and it's the same idea. This one actually has nothing unique. You should have learned all of this in Algebra 2. But again, if we felt like everybody was great at this and remembered all of these methods and stuff, then we would pick a different topic that we felt like would help you more. So. But it should at least come across as being very familiar, which should make it a little bit easier too. Okay, so on these questions, when it says solve, that implies you're wanting to know where y is 0. So we're going to, this whole one, we'll talk about graphing quadratics next class on Wednesday. But this one's all about solving quadratics. So figuring out when the equation equals 0. That's often what we do with quadratics. But we're going to talk about some of the different methods, and then we'll focus a lot on quadratic formula. But on the front page here, I want to remind you there's 4 different methods that you're welcome to use. So if you have some quadratics, some squareds, but you don't have any x's, and this is pretty rare, but you can solve it using normal math stuff. Like you could add 162 to both sides. You could undo times 2 from both sides. You could get rid of a square by taking the square root of both sides. But what I'm concerned about, if you take this approach, is that you're going to do what I did right there. 9 is only one of the 2 answers. This is a quadratic, so we should have 2 answers. Sometimes the answer repeats itself, but we should have 2 answers. And that's when you take the square root of both sides, you need to do plus or minus. So positive 9 or negative 9 works here. So again, if you have some x squared, which makes it quadratic, but not x's to the first, you're welcome to do this. Undo add or subtract, undo multiply or divide, undo square, don't forget to take plus or minus to both sides, and then you come up with an answer. In just a minute, I'll give you time to try question 2, which is like question 1. Okay, another method, probably my favorite method, is factoring. Factoring is the one you probably use the most often, although we're not going to practice it much on this assignment today because we've been practicing factoring on and off for a while. But if you can factor it with guess and check or product sum or any other Algebra 2 method you learned last year, this only works with 0, by the way. This is a special property of 0. If I can make this stuff be 0, then I don't care what this stuff is. 0 times anything gives me 0. Or I could make this be 0 and then not care what this is, because 0 times anything gives you 0. So you said each factor equal to 0 and solve. It's a quadratic, so you should have 2 answers. Okay, and again, in a minute, I'll ask you to try question 4, doing the same thing. Okay, number 3, ask us to solve by graphing. So this is admittedly not one that's going to help us too much in our class, but this would help you a lot on the ACT. If you couldn't figure out how to factor this, you realize you couldn't do that first method because there's some x's there. Maybe you can do quadratic formula, but that takes a while. You could graph it, and you really just need to know what you're looking for here. If I'm trying to figure out where this guy equals 0, I'm trying to figure out where y equals 0. And y equals 0, same thing as saying x-intercepts. So that looks to be at 4 and -5. So on your paper, if you would just sketch a quick little graph that goes through 4 and -5. Graphing is super convenient, but again, you have to have a calculator to be able to do that. All right, and then on to the one that you're going to get the most practice on today, which is the quadratic formula. This is the most important one by far. Quadratic formula is the only one that always works. So if you only know one method, it has to be this method. Well, you got to know this method either way, because sometimes those other methods don't work. So some of these later pages, we're going to break it down and talk about it a little bit more, but just kind of as an introduction here, you need to know what A, B, and C are. A is the coefficient of x squared, B is the coefficient of x, and C is the constant. The first step is you have to memorize the quadratic formula correctly. You need to plug the numbers in as it says to. So opposite of b plus or minus square root of b squared. 8 squared would be 64. Minus 4 times a, which is 4, times c, which is 3. Put all of that over 2 times a. Now, this stuff under the square root has a name. It's called the determinant. And just for time purposes here, I'm just going to have my calculator do that real quick. All of this comes out to be 16. Now, determinant, depending on what the determinant is, changes some of our work. If this is a perfect square, like this one is, it's going to work out nicely in the way I'm about to do it. If the determinant's negative, we end up having to talk about imaginary answers. If the determinant's 0, then you're adding 0 and subtracting 0, so you get the same answer twice. So this stuff under the square root determines what type and how many unique answers you get, which is why it has the name determinant. But for me right here, the square root of 16 is 4. So one answer is going to come from negative 8 plus 4 over 8. In other words, negative 1/2. And another answer is going to come from negative 8 minus 4 over 8, which reduces to, not that, negative 3/2. So you guys know I would prefer factoring anytime something factors nicely. This one must have factored nicely to come up with those reasonable answers. But again, we have to practice quadratic formula because it's the one that is the only method that's going to always work. So know what A, B, and C is. Make sure you have the quadratic formula written down so that you memorize it correctly. Plug in A everywhere it says there's an A. Plug in a B everywhere there's a B. Same with C. Evaluate, evaluate, evaluate. Add once, divide by 8, subtract once, divide by 8, and reduce. So, before we kind of break it down and look at some of the unfriendlier quadratic formula questions, you need to practice one of each of these forms. So, question 2 is just like question 1. So look at question 1 for a second, think about why we could work it differently, and then try to do the same thing on question 2. Then look at how we solved question 3 and how it worked out. You try to do the same thing on 4. I graphed number 5 to get the answers. You graphed number 6 to get the answers. You don't have to do it by hand. And then number 8, try plugging that in quadratic formula and see if you can get the right answer, or at least see where you get stuck. So I'll give you a few minutes to try those 4 questions. And then I'll pause the screen and I'll go over them, or I'll work them out, and then I'll unpause the screen and we can discuss them as need be. And feel free to use the calculator in number 8. Those numbers are too big to try to do without a calculator. So I gave you several minute head start there, and then I worked them as well. So let's see how you did on these. So question number 2, since there was no x to the first, you could just undo the minus 125 with the plus 125, undo the times 5 with the divide 5. What I'm most concerned about is your answer should not have been 5. It's plus or minus 5. 5 and negative 5 work. When you take the square root of both sides, you need plus or minus, or you lost an answer. Okay, number 4, factored nicely. If you set this factor equal to 0 and solve, you should have gotten negative 1/2. And if you set this factor equal to 0 and solve, you should have gotten 3. If you didn't factor it the same way as me, then you need to force yourself to check it better. Check by foiling. Remember that product sum method always works. So if you struggle with factoring, you need to force yourself to go through that process and be very familiar with it so you can do it when you need to. All right, number 6 said graphing. So I threw it in my calculator. Graph looks like this. And y, if you're solving this, which implies you're trying to find where it equals 0, you're trying to figure out where y is 0, which is the same thing as saying x-intercept. So you just had to know which part of the graph you're looking at. 4 and 7. Of course, this method only works if you have a calculator. And then number 8, quadratic formula. I plugged in 19 for B, 6 for A, and negative 7 for C, everywhere the quadratic formula said to. Again, normally you would either, these numbers would be more reasonable, so you wouldn't need a calculator. Because if you have a calculator, you've got other options, so it kind of defeats the purpose. But honestly, I threw all this discriminant in my calculator, got 529. I asked my calculator what's the square root of 529. That was 23. It's a perfect square, just not one that I knew. But then at the end, make sure you know how to come up with these two answers. I did negative 19 plus 23, which is 4, put it over 12 and reduced it. And negative 19 minus 23, which is negative 42, put it over 12 and reduced it. But plug in A, B, and C as the formula says. Arithmetic with the calculator, square root in a calculator, adding, divide, subtracting, divide, and that's where the answers came from. Now again, most of the rest of these pages are going to focus on quadratic formula because that's where y'all need the most practice, but this is just a quick little introduction. So, anything you'd like to ask about 2, 4, 6, or 8 before we move on? Okay, so inching our way out here, we're going to do more quadratic formula in a minute, but unlike these two, they're not always going to, the discriminant's not always going to be a perfect square, and so that can be a problem if you don't remember how to simplify radicals. That didn't come up on page 1 because the square root of 16 is exactly 4. The square root of 529 was exactly 23, but it's not always going to be that way. So our first row here are some that hopefully you could answer pretty much instantly, but I want us to slow down and think about why they work so that we can apply it to other ones that are not perfect squares. By the way, this has come up a few times this year, but never has been really our algebra focus. So you can think of 25 as 5 times 5. You can think of 16 as 4 times 4. 100 is like 10 times 10. And 49 is like 7 times 7. So when you're doing a square root, just like when we say x, that implies we're talking about 1x. Square roots have an understood index of 2. We just don't write the index. That means you need 2 of the same thing under the square root for one of them to come outside of the square root. 2 4s inside makes 1 4 outside. 2 10s inside makes 1 10 outside. 2 7s under the square root is the same as 1 7 out of the square root. It's important for you to think of them this way because 125 is not a perfect square. There's not something times itself to give you 125. So there's a couple ways you can do this, and I will tell you both, but I really think you should do this first method, and I'll tell you why. I think it's better. So what I like to do is called a factor tree. I just think of any two numbers that multiply to this, like, I don't know, 5 and 25. If one of these numbers is prime, it's done, but if a number's not prime, you have to break it down. So 25 could be 5 times 5. So apparently 125, without the need of a calculator, is 5 times 5 times 5. And because this is a square root, I need two of the same thing under the square root to pull out one of them outside of the square root. So these two 5s can group up together and become a single 5 outside. And then this 5 had nobody to pair up with, so he's stuck under the square root. Square root of 125 is 5 square root of 5. We're going to need this for quadratic formula on the next page or two. Okay, the other way you can think of this, and this might be how your Algebra 2 teachers taught you this, although I kind of hope it's not, is you could think of the biggest perfect square that goes into this evenly would be 25. And then square root of 25 becomes 5, square root of 5 becomes square root of 5. So if you can like break off perfect squares from it, then that's fine. The reason I don't like this method as much is because not everything is square roots. Most of what radicals you guys have seen are square roots, but there are things, there are cube roots and fourth roots and fifth roots. And if you do this method, this is called prime factorization. If this was a cube root, I would just group all 3 of these 5s up because I would need 3 5s. If it's a fifth root, I need 5 of the same things to group up. And if you try to do it this method, it gets really complicated quickly. So I think the prime factorization / factor tree is more versatile, so that's what I'm going to do. So instead of calling this the square root of 27, I'm going to call it the square root of 3 times 3 times 3. That's the prime factorization of 27. The prime numbers that multiply to give us 27. And since it's square root, I need 2 of the same thing to group up and bring 1 out front. 1 of the 3's had nobody to group up with. Everything that comes out gets multiplied together. Everything left behind gets multiplied together. Instead of saying 8, you could say 2 times 2 times 2. And when you write it this way, you can visualize these 2 grouping up, coming out front, and this 2 having no one to group up with, being left behind. Square root of 8 is the same as 2 square roots of 2. And instead of saying the square root of 12, we could say 3 times 2 times 2. So the 2 2's can group up and come out front, and there was a 3 left behind. Square roots, you just need 2 of the same thing. Whether it's 2 7's, 2 10's, 2 4's, 2 2's, 2 3's, doesn't matter. You need 2 of the same type of thing under the radical for one of them to come out as outside. Okay, I'm going to skip this row for now. I'll give you some class time to do that next class. I think it would be good to make your brain think about it at a separate time anyway, so don't worry about those yet. All right, on the next page, we will also have to deal with some imaginary answers. So let's look at a couple of these, and then we'll look at a couple on the next section, and then we'll find a stopping place for today. We are on a little bit of a reduced schedule today. Sometimes our discriminant is going to be negative. So discriminant just means the stuff under the square root. And the one you need to memorize is this one. The square root of -1, by definition, is I. This is what we start to call imaginary numbers. Now, even though they're called imaginary numbers, it doesn't mean that they're imaginary. I think this has come up in the past, but the guy who published the work on them thought they were imaginary because they didn't have any uses at that time, but then they figured out they do have uses. All circuitry, computer motherboards, cell phone motherboards, none of that stuff would exist without imaginary, but the name had already stuck. So, for these questions, it's just one extra step. If you have a negative under your square root, bring it out as an I, and then work the rest of it the same way. Square root of 4 is still 2. Negative under the square root comes out as an I. Square root of 9 is still 3. Only new step is bring out the negative as an I. Square root of 81 is still 9. Okay, and then let's look at just one more, one harder one, and then we'll stop for today. So on number 25, again, I think it's a mistake to not just do this at the beginning, but a negative under the square root is the same thing as an I. 216 is a pretty big number. I don't expect you to just know what that is in your head, but a factor tree helps you dissect this information into smaller pieces. I know 2 goes into it evenly because it's an even number. 2 goes into this because it's an even number. 2 is going to go into this because it's an even number. Then 3 could go into this, and 3 and 3 make 9. So the prime factorization of 216 is 2 times 2 times 2 times 3 times 3 times 3. 2 times 2 times 2 times 3 times 3 times 3 is 216. Now, I couldn't have told you that in my head, but again, this is where the factor tree lets you do it in small, manageable chunks. Now I can see there's 2 2's that could group up, there's 2 3's that could group up. So I'm going to bring out a 2, a 3, the I's already out there, and left behind is a 2 and a 3. Everything that comes out front gets multiplied together. Everything left behind gets multiplied together. Negative square root of negative 216 we will need to change to 6I square root of 6. And again, we're practicing this part so that we can do the square root part on quadratic formula when we need to. All right, so we are actually down to about 5 minutes with our reduced schedule, so we are going to stop here for today, and we'll practice a little bit more of this on Wednesday together in class, and then I'll save a couple of these for homework for you on Wednesday in class. But for now, you don't need to worry about it unless you feel like this is a lot harder than you remember. Then maybe you should practice.